Hello class, I just kind of wanted to show some of the uh, answers, or all of the answers to our worksheet here. I just wanted to kind of walk through them and explain a few of them to you, and I hope to kind of help you learn this process that we go through when we do our electron configurations. So first things first, let's look back at our notes. So when we go to electron configurations, I believe I posted these slides last week. We started off by talking about our different shapes, what our S, P, D, and F orbitals actually mean, what they look like that's different. We talked about their energy levels and how they're different, and then we got into writing our electron configuration. So when we write our electron configurations, the number in the front is the electron shell. The S, P, or D is the suborbital or the shape of the electron that is in, and the exponent is the number of electrons. So then we look at our periodic table to find out where each one of our different subshells, S, P, D, or F, are located. So at the beginning, this left side, we have our S's, and then we also have this weird little outlier that is helium all the way over here. In the middle, we have our D's. Our D's are all our transition metals is another way we have talked about this group. And then our S's are alkaline metals and our alkaline earth metals, to use some of that same terminology, those same words that we've used to describe them before. And then we have our P block. So this is everything on the right side, and then this extra box on the bottom is our F block. We won't be working much with our F blocks, but I really want you guys to know how to do the S, D, and P blocks. So we also had a nice little electron configuration periodic table. So it looked a little different than our normal one. Let me bring that in. So our normal one just looks like this. We don't have our blocks or anything written out, but I found a nice one to help us learn this that has each one of our electron configurations. So, for example, our first one is fluorine. So fluorine, what we would do is we can go to our nice electron configuration table of the periodic table, and we can just find fluorine, which is over here, and then we just step our way, read our way through the table. So it would be 1s1, 1s2, 2s2, and then 2p, 1, 2, 3, 4, and 5. We stop at 2p5 because that is where fluorine is located, so we have reached the element we want to. And so we write them just in that order. We write them in the same order as if we were reading a book, right? So our first thing that we read is our 1s2. Oh, let's find this. So 1s2. And then the next one we had was 2s2. And the last one we read was 2p5. So 1s2, 2s2, 2p5. All right, let's keep working through these. So our next one is potassium. So let's first find potassium. Potassium is K, which is over here. So it would be the same start. It'd be 1s1, 1s2. So you'd write 1s2, 2s2, 2s1, 2s2. We fill both of these electrons up because we have to get all the way down to potassium. And then we fill all of our 2p shells, so it'd be 2p6, 3s2 because we're filling both of these, and then 3p6 because we're filling all of these, and then we will end with 4s1. We have a little 1 even in our periodic table. So when we write those out, it would be in this order: 1s2, 2s2, 2p6, 3s2, 3p6, and our last one would be 4s1. So that would be our complete answer. All right, let's do our last one for our full electron configuration. So Aluminum is over here. Aluminum is Al. So it would look very similar to the ones that we've always started, which is 1s1, 1s2, 2s2, 2p6, 3s2, but we would stop at 3p1 because we got all the way to aluminum. So same thing, 1s2, oops, sorry, 1s2, 2s2, 2p6, 3s2, there we go, and 3p1. So this can be a lot of writing, and if we can notice anything, it's that these all begin the exact same way with 2s2, 2p, or sorry, 1s2, 2s2. So a way to, once we understand this, to have a shortcut is to write the condensed electron configuration. So condensed we learned about as well. It's a little bit different by having a start at the nearest noble gas, and we continue our process. So when we have condensed electron configuration, for example, if we were to do it for fluorine, our last noble gas would be helium. So what we would write would be, this one is in the wrong spot, but what we would write is helium, and then that would get us through the first row, and then we would go to the second row, 2s2, 2p5. So by writing our nearest noble gas, all we are doing is simplifying a whole row. This gets really helpful when we get down into having to do things like silver Ag or gold Au, or I don't know, any one of these elements that are far down here. Instead of having to write everything out before it, we can just write the nearest noble gas. And if we remember, our noble gases are all in this far right column. So let's work through our condensed version. So we got to find gallium. Gallium is Ga, which means it's right here. So our nearest noble gas is argon, Ar. Ar, and then we would go 4s2, now 3d10, and 4p1. So let me write that and then explain one more thing. Oops, I did not mean to do that. 4p1. Okay, so what we notice is we now have an exception to our rule. When we get into our D block, it is our number in front is one less than the row we're in. We're actually in row 4, 1, 2, 3, 4, but we're in, for our D block, 3D. The reason there's an exception to the rule is it has to do with its energy level. So the shell number 3 for our D orbitals has the same, or similar, I should say, energy to our 4s and our 4p. It's actually right in the middle. So this is why the order is a little bit different, is because it always has to do with our energy levels. But an easy way to remember that is either that our D shell is always one less than the row it is in for the number, or if that's too confusing, we can make this nice easy table. So the way this works is you write 1s, 2s, 3s, all the way through 7s in a line, and then you do the same thing with 2p to 2p to 7p, 3d to 6d, and 4 and 5f. So this is easy to remember. All of our rows are in the right order. It always goes S, P, D, and F. But to make sure we get all of our letters in the right order, we do them in diagonal and kind of loop back around. So we would start with our 1s like we've seen, then we go to our 2s, our 2p, our 3s, and then our next energy level would be our 3p, 4s, and then from our 4s we go to our 3d before going back to our 4p, 4s, 4d, 5p, 6s. So we can see that pattern come up right here when we have our 4s, 3d, 4p. So however is easiest for you to understand that is the one tricky thing about doing our electron configurations. Otherwise, it's the same process for our it's a very straightforward process. So let's do cesium. Cesium is a great example of how this this condensed electron configuration can be really helpful. So cesium is right here. So our nearest noble gas is xenon. So what we would do, our xenon is xenon, and then we would write 6s1 because our cesium is on our 6s1. So rather than writing 1s all the way through 5s2, 4d10, 5p6, and then 6s1, we get to skip ahead because of this noble gas. Alright, so the last one I'll show you as we are running out of time is silver, and then I think you guys can work through calcium and selenium after looking through these. But silver is Ag. So our nearest noble gas would be krypton. As we're reading our book, the last one that we would have read before Ag in our noble gases would be krypton. So we would do Kr. And then 5s2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 4d9. So 5s2, 4d9 is our answer. So s2, 4d9. So I hope this has helped you guys kind of see the process, at least maybe the way I do it. Maybe it will help you understand it a little bit better. The goal for all of these electron configurations are to be able to do them using a periodic table like this, so that we can memorize that this is our S block, this is our D block, and this is our P block, is the goal, so that we can do these without looking at a special table or any other way, because this is the table I'll give you on the next exam. So keep on working. If you have questions, please let me know. I'm always here to help.